So we've looked at finding inverses based on functions. Well, we can also do the same thing from a picture. And so what this problem does, it's provided you information to draw two segments. So we're going to graph those first, and that's going to be our f function. And then based on that, we want to find the inverse. You can do it by looking at points as well as on the graph. So I'm going to show you both of those so that we can have different ways to do that. So my first point is minus 2, minus 2. So I go to the left 2, and then I go down 2. And then my next one is minus 1, and I don't go anywhere. So it's right there. So I'm going to draw a line. Now the next one says I'm going to go from negative 1, 0. So that's where I ended. And now I'm going to go from 1, 2. So that's up here. So I'm going to go over there. Now, looking at the graph, I would be able to find the inverse right away. First, I want to show you another way, an alternate way to do that, is we can actually create kind of like a t-table. So I can actually have my points from f of x. So I have the point negative 2, negative 2. I have the point negative 1, 0. And then I have the point 1, 2. So if I find the inverse, remember when we did the inverse, we exchanged x and y. So I'm just going to reverse the order of my ordered pairs. These are both the same, so it still looks the same. This one becomes 0, negative 1, and this one becomes 2, 1. So if I were to graph this second round, I've got negative 2 and negative 2, so it's still going to be in this same spot down here. And then I'm going to have 0 and negative 1, which is right there. And then I'm going to have 2 and 1, which is here. So it kind of comes up like this, and then it comes over like this. And what you notice, if you look really carefully at this, is there's an imaginary line that goes directly between them. And so what you're actually do is you're reflecting it across that imaginary line when you find the inverse.